Hi, in this video we are going to discuss about how to solve the problem image transformation which was given as POD on 24th November. So let us just recall the problem statement. When you look at the digital images, they are basically represented as a matrix and each element in the matrix represents the RGB value. When you look at the colored image, the colors are combination of red, green, blue. That is how it is internally represented. And the basic representation of image is a huge collection of pixels. So it is a matrix representation basically. So given the pixel values of a n cross n image, write a code to transform the image into another image by alternate swap of edge pixels. This is what is the problem. So to understand what is meant by alternate swap of edge pixels, let us take a 4 cross 4 image as shown below. Okay, and let us see what will happen here is first you have to start with the first element of the matrix and I have to swap with the alternate element. So when I take the first element, it will be swapped with the third element in the first row, and then only edge elements are going to be taken. Okay, so what I mean here is you are not going to take the other things, right? So you will be taking only the edge elements. So edge elements in the sense you will be considering only these elements. Okay, these elements are only going to be considered and it should come in this way, right? So this is the direction in which, so when you look at the example you will understand. Now I am just describing that this is the way in which you should move. So when you are going to move, what you are going to do is, now I have to swap 1 and 3 and here 1 will come. So the element at this position is 1. So the element at this position should be swapped with the element which is 1 after the particular element in the position, and then here will be the 1. Now this 8 will go there and 1 will be here. Now 1 should be swapped with the 16. Here 1 will come, 16 will go there. Now 1 will be swapped with 14 and then 1 will be swapped with 9. That's all. Okay, one should not go back to the place. So this is how the swapping will happen if you are going to have even number of elements, that is, if n is even number. That is what is described here. So what are the edge elements that is being listed down, and it shows how the elements are going to be swapped. Now so after the swap of edge elements, the matrix will look like this. Now let us take another one example, a 5 cross 5 image. So in the 5 cross 5 image, you will start from the first element, swap it here, right? And then you have to swap these two elements positions, right? And then here, and then here, and then here, and then here, and then that's all. Okay, it will not go here because when I go one step after it, it will be the original position of the first element. So this is how it is going to happen, and you will see the transformed matrix will be like this. So let us see how we can solve it, right? This is a 4 cross 4 matrix and this is a 5 cross 5 matrix. Already we discussed. So when you are going to implement, actually there are two ways in which we can implement. There are two alternate approach. Approach one is, you can have, first of all you are going to create an input matrix. You are going to read the values. Input is a matrix. You are going to read the elements of the matrix and you are going to swap the elements in the input matrix itself. That is approach 1. Let us see how it is, what is the complexity of doing that. Okay, and approach 2 is you are going to collect the corner elements alone, put it in a list. Okay, and then you will do the swapping and then replace the corner elements in its original positions. Okay, you are going to replace the elements in the input matrix so that it will get transformed. This is approach 2. So let us discuss the first approach first of all. So in the original matrix itself you are going to do the change. So what I have to do, I have to when the elements, number of elements is going to be even. Okay, when the number of elements is going to be even, what I will be doing is I will be swapping the first and the third element, right? And this this row, okay, I will stop. I don't have anything. See how I am going to process now is, I will look at only the first row, right? And then I will be looking at the last column, like that I am going to now view, and then last row and then the first column. Okay, this is how I am going to do. Now I will concentrate only on the first row. So I will swap the elements 1 and 3, and then I will be trying to swap the element 3 with whatever its row, but nothing is left out in the row. So what should I do is, I should start the column processing, last column processing now, and I should swap the element with the last column, and then from here I will be swapping with this one, right? And I have reached the end of the last column. Then now I should process the last row. So I will be trying to swap with this one, right? And when I am trying to swap the element in this position with some other element, nothing is left out. Okay. So what will I do? I should now change from the last row to the first column. So this element have to be changed with this element, right? And then that's all. Okay, when I am trying to make here, I will find that I come back to the original position. Similarly, so in this method, actually for this example, what is the drawback is, okay, there is a drawback in this approach. I have to be very conscious about the position of the element, because when you look at this element, okay, when it has to be swapped, they are neither in the same row nor in the same column. I may get, okay, of course it is doable, not very much complex, but it will be thought process more involved, and we can change if there is an alternate approach. Okay, so this is the drawback, because and when I come back also, from here I have to swap with this element, right? When it will be easier when we are in a linear fashion. Okay, if I want to swap between the first row elements, if I want to swap between the last column elements, and then it will be easier. But when I want to swap to different positions, I may have to think a little bit more. Okay, that is the first drawback we have identified when we are processing in this manner. Let us come back to 5 cross 5 matrix. So when you are going to have the value of n as odd, then what you have to do, I have to do the swap here and then here. Okay, this is purely on the same row I can process. Now I have to swap this element and this one, right? And then this element and this one. Of course, it's nice, this to this and this to this. Okay, this to this. That's all. I will stop. So here the drawback is not there. Okay, this is odd number of elements means that drawback is not there. This is the difference. So the second thing I have to do is, I have to deal odd dimension. Okay, if the dimension of the matrix is odd and if it is even, then my approach should be a little bit different. So that also I have to take up. These are all the, anyway you have to traverse the corner elements. That is common for both the approaches. But when you look at the first approach, we see that this will be some creating some hitches in my implementation. That's what, right? So now next method approaches, you are going to pick the corner elements alone and keep it separately. So when I mean the corner elements, I want to pick all these, okay, followed by this and then followed by this and then followed by this. That's what I am going to do. So what will I do? I will take 1, 2, 3, 4, right, 8, 12, 16, 15, 14, 13. This is what I want. This is what I want. And then 9, 5. These are all totally column edge elements, but I want only the alternate edge elements, right? Because that are only going to get swapped. So I will take 1, 3, okay. Then I will be taking 8, then 16, right? And then 1, 3, 8, 16, and then 14, okay. And then I will be taking 9. That's all. Okay, these are all the alternate corner elements. So if I could take this, it will be easier for me, right? What I can do after I take these corner elements, I can swap the alternate elements. Okay, I can just swap the alternate elements and then I can replace that. That's what. Okay, I can do that. That is what we are thinking. Or else you can pick all the corner elements also, no problem. Okay, sorry, if you are going to take these elements, then you have to pick only the, you have to swap the adjacent element. This logic will be different from this one. Okay, sorry, let us follow this itself. We will pick all the corner elements and we will be swapping the alternate elements. So 1 and 3 will be swapped, and then from here will be 1 and 8 will be swapped, and so on. And then we will replace the first row and then the last column, last row, and then the first column. So what we will do, if it is odd number of elements, we have to take 1, 2, 3, 4, 5 and then you have to take 10, 15, 20, 25, 24, 23, 22, 21, okay, 16, 11, 6. These are all the elements. These are all called as corner elements. We will take the corner elements and then we will try to replace it. We will swap and then we will try to replace it. So, if it is a general n cross n matrix, so what is the advantage in the second approach is you need not make any change in your implementation based on whether the dimension is odd or even, and there is no such hitches, right? When I want to, I can traverse in a linear fashion. That is very comfortable for me. When you look at approach 1, I have to do some non-linearities, that is from different row and column. I have to swap with different row and column, that I am going to get rid of if I am going to follow approach number 2, right? And when you look at the general n cross n matrix, there should not be repetition, isn't it? So when you are going to take the corner elements, I will take first of all the first row, okay? This is generally I have written E, I use this letter E to indicate the element. 1, 1 means it is in the first row, first column. This is first row, second column, first row, third column, and it's a n cross n matrix. So the last element will be E1n, first row, nth column. And look at the last column elements, all are at nth column, E2n, E3n and so on, and the last element is ENN in the nth row, nth column. And when you look at the rows also, last row elements, you can see En, nth row, n minus 1 column, n2, n like that. And similarly, these are all the first row elements, first column elements. Okay, so you can see the column index will be 1. Now what we are going to do is, we are going to basically take the first row elements. So I will consider this 1n as a part of the first row. Okay, so from E11 to E1n, I will consider entirely as the first row elements. And then what I am going to do is, I am going to consider the last column elements. When I am going to take the last column elements, I am going to include ENN. So from E to N, I have to consider up to ENN, right? And then I will take the last row elements. So when I want to take the last row elements, I have to go in this order. So it will be from En, n minus 1 to En1, okay? And I have to consider the first column element. This is already a part of first row, that is already taken, and this is already a part of last row, which is already taken. So I have to start from here, En minus 1, 1 up to E2, 1. This is the overall idea. And we know that in programming languages, the index of the elements are going to be from 0 to n minus 1, right? And this is row index, this is column index. So when we code it, we will come back to this and have some idea about how to code it, right? Before coding, let us just look at the input format, what is given. So the input format given is, the first line contains the dimension of the matrix n, and then next n cross n lines contains the elements of the matrix in row major order. So what is meant by row major order is, first row elements will be given first and then second row elements and so on. That is also given here. And when you look at the output format required, you have to print the transformed n cross n matrix in n lines, okay? And each line should contain the element of a row separated by a tab, and there is also a note that there is a tab at the end of each line. Actually, sorry for leaving a small mistake. When I gave the test case, for the first test case alone, there was not tab. Really sorry for it. Later on I identified and I corrected it. Okay. So this is the output format required. So let us look at the implementation and we'll proceed, right? So let us write the steps involved. First thing is, you have to read the dimension of the matrix. Okay. First thing is, read the dimension of the matrix. Second thing is, read elements of the matrix and form the matrix. Okay, form the matrix. That is step 2. And then what you have to do is, take corner elements of the matrix and form a list. Okay, and then what you are going to do, swap elements in the corner list. swap elements in the corner list, and then what you are going to do is replace elements in matrix with corner list elements. Okay, it will be in proper order. We will follow the same ordering what we followed while we picked up, and the last step will be to print the matrix. Okay, done. So first thing is read the dimension of the matrix. Let n be the dimension of the matrix. So I want to convert it into an integer, and then I am creating an empty matrix. So how do we represent matrix in Python? It is going to be list of list. So this is the outer list, and you are going to read the elements of the matrix. Okay, so I am going to do it row major ordering, since it is given in the problem itself that it will be row major ordering. Anyway, it's a square matrix, so number of rows and number of columns are same. What I will do is, first of all, I will add a empty list into the matrix. This is for storing the element of one row. Just understand that how do we represent matrix in Python is, you are going to have a list of list. Okay, each list in the list is going to represent one row. Okay, so first of all you create a empty row, and then you are going to add it, right? And then I have to go for the columns. So for j n range 0, n, you are going to read the element from the user, right? They are going to convert it into a integer, right? So let me have a temporary variable ele, and then you are going to append it. Where you are going to append it is, it is the element of the ith row. So you should say matrix of I dot append of ALD, right? So this is how we have to say. So the matrix is now ready. Let me print the matrix now and show you. So yeah, how will we print it for in range? Okay, 0, n, for jn range 0, n. I am going to print the elements of the matrix. So matrix of I, j, and I do not want to move to the next line. By default, Python moves to the next line after printing. I do not want that to happen. So I am giving end equal to tab. That is what is specified in the problem. Each element is separated by a tab. So now it will be printing the elements. After I finish one row, what should I do? I should move to the next line. So for moving to the next line, if I just give a print, it's enough. It will move to the next line. Okay, and let me go to the terminal and execute it. Yeah, so let me check it. Okay, so now it is executing. Let me say 4 and give the element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so the matrix is now ready. You can see that it's a 4 cross 4 matrix and it is formed. Now what should we do next? I should take the corner elements of the matrix and I should form a list. So first of all, let me create a empty list, right? And then I am going to take the corner elements. First I am going to traverse the first row and I am going to take the elements. So let us look at it. So I have to have a for loop, obviously, isn't it? For, let me write like process first row. Okay, that is what we are going to do for I in range. Okay, and I am going to do what I am going to do. I am going to anyway traverse the first row elements. Only column is going to change. So I indicates the column value. Okay, row is going to be always 0 index because it's the first row, and I want to take all the elements and I should start from 0 and I should go up to n minus 1. I should go up to n minus 1. So how will you write the ranges? You will say up to n because range has the property that it will take 1 less than the stored value, right. So you are going to take it and I will add it to the list. Which one? The first row and the ith column element, okay, matrix of 0 and I. Next I am going to process the last column. I am going to process the last column. I am going to do this, right. I will not consider this element because this element is already included as part of the first row element. I have to start here. Here the row will be changing and column is fixed. I am going to process the last column. We know the index of the last column will be n minus 1, okay, and the row is going to change. Where I should start the changing of the rows? I should start from 1 and I will go up to n minus 1, right. So let us write once again with I, because I is already over, so I can use the same variable. I will start from 1 and I have to go up to n, right, and I will say corner dot append, right, corner dot append matrix of, here row is the changing one, column is fixed one, right. So column is n minus 1, the changing one is the row. So I will include these two. Next I have to process the element in the last row, okay. So let me say process last row, right. So for I in range, since the loop is getting over, I can use the same variable. See, when you look at it, this is also part of the last row, but already it is included as part of the last column. So we need not include this element ENN. This is not going to be included. So I have to start from here and I have to go to the first column, okay. I have to start from the n minus 1th column and I have to go to the 0th column and in the reverse direction. That is the change here. But when you look at these two things, it was in the increasing. You can see that it will be from 0 to n minus 1, here also from 0 to or 1 to n minus 1, it was increasing. But in this case we are going to go in the reverse direction. From n minus 1 I have to go up to 0, okay. So actually the n minus 1th element will be at the index n minus 2, okay. N minus 1 index will have the nth element because the index starts with 0 and I have to go till 0. When I have to go till 0 and it is going to decrement, I should give as minus 1. So I should stop when the value of I reaches minus 1 and the step value is also going to be minus 1 because I want to move it in the reverse direction, right. Now what we are doing is we are going to add the corner elements to the matrix, right, and what is going to change now? Now row is fixed, row is going to be the last row, okay, and column is the variable thing. So let me say matrix of n minus 1 of I, done. Next what we are going to do is process the first row. So let us look at the matrix. So when I want to process the first row, actually the elements are from E11 to En1 and I have to come in this direction, then only I will get the desired thing. When we look at it, this En1 has already had been included as the part of the last row. So I need not include it now, okay. And similarly this E11 was also included as part of the first row. So I should not include it now, right. So what should I do now? I should start from here, right, from the index n minus 2 and I should stop at index 1. I should stop taking the elements when I reach the index 1 and it should be decrementing, right. So let us write it for yeah, hope this is fine, yeah, this is fine. For I in range, I should start from n minus 2, okay. I should start from n minus 2 and I should stop when I reach 1. So after processing 1. So I should stop when I reach 0 and the index is going to be minus 1, okay. And now we are going to update your corner elements. So you will have matrix, it is going to be the first column and row is the variable. So I should give I and column is first column, so 0. Okay, so this is how we will pick the corner elements. Let us see, print the corner elements and see. Print corner. Fine. Yeah. I have a small issue in running on this, so let us take this. So I am taking 4, 1, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So you can see that the corner elements that are included are 1, 2, 3, 4. Yeah. These are all the elements. You can see it. It's there. And then 12 is included. Okay. 1, 2, 3, 4, 8, 12. 8, 12, 16, and then 15, and then 14, 13, 9, 5. Okay, so we have got what we want in the corner list. Okay, we have got what we actually want. Now after that, what should you do? You should swap the corner elements. Okay, so how can we swap it? I am going to do it like this. For in range, I am going to traverse the entire thing. So len of corner, and then I am going to do only the alternate things. Okay, so let me take it as 2. Okay, because I want to swap 1 and 3. After that, in this index, from this index only I will swap the next one, right? So my loop is in the corner list. I am going to start from 0 and I will go till the end of the list len. And I will be jumping to 2 places, right? This is what I am going to do, and I will go till the end, right? I have to go till the last. Okay, so is that correct? Or what we can do is, I will do in this way. Okay, I will better write and show. See, for example, if I have got for example, let us take the same thing, 1, 2, 3, 4, right, 8, 12, 16, 15, 14, 13, 9, 5. Okay, these are all the elements. I have to swap these two and then swap these two and so on. Okay, so when you look at the position at 0 and position 2 is swapped, position 2 and position 4 is swapped, and so on, right? So when I am going to start, if I go till the end, I can start from here. I will say that swap the element from here to here, right? I will say swap the element at I with I minus 2. That may be easier, or I should change. I should either change the starting condition or the stopping condition, because I don't have any element to swap for the last one. Okay, so I should not. If I go, I'm going to say I is the starting value, is the position of the source. Okay, then I need not go up to the last element. I hope you can understand that. I can go up to 13 alone. I will swap 13 and 5, that's enough. I need not go till that step. That is one way. Or else what I can do is, I can say that I will start from here, okay, and I will go till the end. But when I say swap, I will say index at position I and I minus 2 is swapped. I am going to follow the second one. So let me code it. So I am going to start from 2. 2. So I am going to start from 2 and I am going to say corner of I minus 2. How do we swap in Python? It is very simple. Corner of I minus 2 and corner of I are going to be swapped. So I say corner of I minus 2, corner of I is equal to corner of I, comma, corner of I minus 2. I hope all of you know how to swap. For example, if you want to swap two variables a and b in Python, it is very simple. A comma b equal to b comma a. This will do the job. It is not required to have a temporary variable and have some intermediate assignments and so on. Okay, so here I want to swap the elements at position I and I minus 2 of the corner list. So I am saying corner I minus 2 is comma corner of I is equal to corner of I comma corner of I minus 2. This will do the job. So swapping is done. Okay, and then what I am going to do is, I have to replace back the elements. So how I am going to replace back? It's very simple. Whatever we have done already, you take that and you replace, that's all. Okay, so I am just going to take a copy of it, because I need not, because already I have seen the how to transit, right? So I need not worry much about it. I can just do the change of what I am doing here alone. What I am going to do here, I am going to change this matrix of I will do two things. I will have one index for the corner element alone. I will say current equal to 0. This will say the index of the element which is going to be replaced from the corner list. Okay, so let me say corner of CUR and then CUR plus equal to 1. I am going to increment it, that's all. Okay, this is what I am going to do basically. So for each of the things, after processing the first row, I am going to process the last column, same thing. Okay, after processing the last column, I am going to process the last row. Okay, after processing the last row, let us process the first row. Okay, that is not printed, that is not required now. So this should work. Let us see. Yeah. Now 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Yeah. So you see that now the elements. Let us check with the content in the slide, because we have got this example. 3, 2, 8, 4, 5, 6, 7, 16, 1, 10, 11, 12, 13, 9, 5, 15, 14, right. So we have another example. Let us give that and check. This is a 5 cross 5 matrix where I should give 2, 4, 5, 6, 3. 2, 4, 5, 6, 3. That is the first row. Second row is 3, 11, 12. 3, 11, 12, 7, 9, and then 7, 15, 13. 7, 15, 13, and then 8, 1, and 2, 21, 25, 13, 14, 17, 10, 16, 19, 3, done. Okay, let us see. 5, 4, 3, 6, 1, 3, 11, 12, 7, 9, 2, 15, 13, 8, 3, 2, 21, 25, 13, 14, 7, 10, 17, 19, 16. Okay, so it's done. Hope the things are clear. So always there may be an alternate way to solve a problem which may make our implementation easier. So we have gone with the approach 2 in which I had some comfortness in doing the processing. So always you can think of the problem whether there can be an alternate approach, that will be good. Thank you.